Hello everyone. Thanks for joining our MecSoft webinar this morning. And our topic today is RhinoCAM in education. Just a note here, if everyone hopefully can hear my voice and can see my screen, if for some reason you can't, go ahead and drop us a chat note there in the chat window and we'll see if we can help you out behind the scenes. Okay. Just some housekeeping tips before we get started. This webinar is being recorded as we do all of our webinars, and we'll make this available to you in a few days after the webinar is done. And also, we reserve the last 10 minutes of every webinar for questions and answers. If any time during the presentation today you have a question, just type it into your chat window in your GoToWebinar dialog, and we'll be able to see it here. And if for some reason we can't get to your question during the last 10 minutes, we'll follow up with an email with the answer. We'll make sure you get answers to all your questions. And with that, we're going to go to our agenda for today. We have a very special guest with us today, Paulus Musters. Paulus is the Material Labs Manager for the University of Arizona, College of Architecture and Landscape Architecture. Paulus is going to show us some pretty cool projects his students have been working on with the help of RhinoCAM. And then we're also going to be showing you some additional case studies of other students who have been doing projects with RhinoCAM. Those are cool also. We will have, after that, we will have actually a tag team demonstration. Kyle Hutchins, he's a technician and trainer with McNeil & Associates, and myself. Kyle will be showing us a part that he's designed, and he has passed it off to us, and we're going to show you how we programmed that part to machine it. And then after that, we're going to show you some resources for RhinoCAM in education. And let's go ahead and get started then. Paulus Musters is the Material Labs Manager at the University of Arizona, College of Architecture. Hi, Paulus. How you doing?
Yes, I'm good, Don. Thank you.
Tell us about how you're using RhinoCAM and how it fits into your curriculum there at University of Arizona. And we have some other slides here, so just when you're ready to go to the slides, just let us know.
Sure, you can go to the next slide. Here at the university in the College of Architecture, we're using Rhino pretty exclusively for 3D modeling and design. So RhinoCAM, MecSoft's product, was a great fit for us. And the way we use it, it's integrated right from the beginning classes, like learning how to use RhinoCAM to generate the G-code for our CNC router. Here you're looking at a pretty sophisticated project that took a couple of years, but the CNC element of it was to machine the molds that created those ceramic pieces that you're looking at there, which basically is something similar to a CMU block. So we're making a tiled wall for a house structure. It has to let light in as well as keep the heat out. I'm in the desert Southwest, so that was some of its parameters. But the CNC created the shapes along the outside just based on line. So it was about how to use the CNC creatively, not to model these things, but to actually allow the tool pathing to create designs itself. And you're looking at a final product there. You can go to the next slide. So this is a process shot of making the ceramic tiles, these CMU type blocks, which took about, again, a whole summer to produce several hundred of them, and we made a wall. Again, the master molds were cut out of MDF on the CNC, so the software allowed for that kind of precision. And also we directly CNC'd plaster molds in order to create these ceramic pieces that you see here for, again, prototyping. That was a very quick way to do that. So you're looking at basically how to integrate that software into their design creativity.
So RhinoCAM was used to machine the top half of that ceramic mold. RhinoCAM was used to machine an MDF cavity that actually molded the top part that is actually the mold. Is that what we're looking at?
That's correct. On the left, you can see that there's an MDF master mold, and then there's a very specific type of ceramic mold that's full of a mold duct that allows air to punch through the plaster to knock the clay off of the mold after you press it.
Mm-hmm.
So, and we've done several other, again, that's a very elaborate procedure to get a master mold to pull, thousands of tiles out of. But first we would prototype and directly carve into the plaster itself. And again, the software allows us to quickly have different iterations.
Mm-hmm.
So we were CNCing plaster, yes, which is a little bit of a trick. We can go to the next slide. And this slide in Ben's product, same thing. You're looking at a final mold on the right-hand side in corian that we machined out. And there's a very good shot on the right center that shows the ball coming from a radius point and getting larger as it's moving away. So they worked a lot with that. And in this case, what it does is refract the light. So this is basically a wall of light being refracted through a glass aperture opening. And we also machined in the corian to make masters to pour the glass in. So all of that was done. Mostly this is using the software creatively. Yes. And here you see prototypes on the left, rubber molds being pulled from the prototypes, and then glass being poured into that. And then we had a final one on the upper right that is the graphite mold, actually. So we machined that out as well. And you see molten glass being poured into there.
So those apertures, they're shown on the bottom left, right? They're little triangular.
That's correct. Yes.
Those are glass?
No, those are prototypes. That was plastic. Okay. But on the right-hand side was the final part. So again, the CNC allows for a lot of iterations, which you can see on the left-hand side. Mm-hmm. Just to quickly make something, the plastic imitated what the glass was going to be, because that was quite an investment in time, right, to go to the graphite mold and then actually do the pouring of the glass. So yeah, that was quite a project. And you can see in the upper middle the CNC happening in progress there with tiny little bits. Yes. Yep. Yeah, so it's a great creative tool. If you do something, it's just part of our process. And here, this shows it really well. It's going to become something else. So each student actually learns to use RhinoCAM, and they learn how to cut their toolpaths themselves? Yes, they're required to make their own file and run the CNC in the beginning. That's cool. Yeah, it's scary, actually. No, that wow wasn't a scary wow. That was a cool wow. Well, it's a cool wow, and really this is an introduction, just like all of our other tools. I mean, there's 10,000 square feet of tools, so ceramics, glass, plastics, vacuum forming, spin casting, all of these things are introduced, and then in their upper level classes, as they move forward, they get to decide if this is going to play a part in their designs or not. Right. Okay. But you are looking here at something that was a 2-year process. Okay. So they learn RhinoCAM at the beginning of this process, and then if it fits into what they're wanting to design, then they know how to use it, and they'll just run with it. That's correct. Okay, cool. Yes. Let's see. I think we got another slide that shows the results of this. Okay. Yeah. Yeah, that's a beautiful wall doing, again, testing on the right-hand side, and that is slip cast ceramics that were fired in that hollow mold, and you see the slip cast on the left-hand side. Again, that was machined directly for all the prototypes in the plaster on the CNC. Okay. So yeah, it makes a beautiful product. So the one in the bottom left, is that a plaster, or is that the actual? That is a ceramic unfired. Okay. Ready to be fired, yes. So that's a slip slip cast.
Okay.
Hollow.
Mm-hmm.
You can tell that there's in those holes, those apertures, there's a hollow space in there, and then there's another wall of ceramics on the inside.
Right. You can see that in the bottom right here.
Yeah. So it was a beautiful design. So again, all the prototyping, we could model that very easily in Rhino and then simulate that in RhinoCAM to see what that was going to look like before we went to the final, even the prototyping.
So the spreading of the light there in the bottom right, that's all done by the glass aperture and the machining grooves that you've machined into the sidewalls?
That's correct. And this was an entire wall, so the refraction of light caused a rainbow of colors around each one of the tiles. As the sun was moving, that would all change.
Oh, okay. Well, that's pretty cool.
So yeah, think about inside of a church and the stained glass windows.
Mm-hmm. Yep.
Yeah, it had that kind of effect. It was quite beautiful.
Paulus, I just wanted one note here. Users may have some questions. Could you hang around with us for the question and answer session?
Yes, of course.
Okay. Okay, great. I appreciate it, Paulus. Thank you very much.
Thank you.
Okay, next up, we're going to show some additional case study projects of other students using RhinoCAM in some pretty cool ways. So let's go right into our next slide. Here we see student projects from the Rhino Fab Studio in Miami, Florida. These are students, typically these probably are high school students, entry-level students, and what they're making here, you see skateboards here leaning up against the wall, and each student gets to design and manufacture their own skateboard. And what you're seeing on these images here on the top right and top left is the actual 3-axis roughing RhinoCAM toolpaths, and what they're doing is they're machining a form which will actually be used to compress the shape of the skateboard into its final form. So the skateboard is like a laminated series of wood and glued together, and these forms actually make it form its shape. And also on this next slide, it's pretty cool. The students actually design some laser etching designs for the underside of their skateboards. And they use RhinoCAM, obviously machine this, but they use Rhino to create the geometric or organic, I should say, design that they etch in the bottom of these bottom laminate side of the skateboard, which is pretty cool. In this next slide, this is from the University of Washington at the College of Built Environments. And they make a lot of different wood crafted products, not just wood, but other materials as well. But here we're just showing 3 examples of some of their projects they've made with the help of RhinoCAM there at the University of Washington. Here you see on the left a milled rocker made out of cherry, and that's a pretty cool design. You could easily see that in a high-end furniture store. And then we'll skip over to the right. You see some casted patterns. It looks like medium density foam. Looks like they're cutting in medium density foam and probably cast some patterns from that, from these parts. And you notice these little tabs in each of the parts. Those can be added automatically by RhinoCAM when you do a 2-axis profiling operation, or you have exact control on where you want to place them, but those are all done by RhinoCAM. You don't have to model those. And then in the center, it looks like they're having a show and tell project with a number of different cool projects here lined up both on the floor and on the table using RhinoCAM for those projects. So now what we're going to do is we're going to do a tag team demonstration. I'm going to switch it off to Kyle Hutchins, a trainer and from McNeil and Associates, and he's going to show us a part that he wants us to machine. Just one moment.
Hi guys. So this is a part from a client that I had a while ago, and this is actually a full-size race car. We designed a body. This is for Advanced Composite Products. The owner of this company's name is Kerry Hitt, and he's also a championship-winning Trans Am race car driver. And so his company builds and manufactures carbon fiber bodies for IMSA Trans Am body or Trans Am race car chassis. And so in the course of this project, we not only designed all of the body parts. Each one of these pieces are giant chunks of foam that they then machined and turned into molds for to lay up a carbon fiber body. But we also were looking at the wheels, and I figured that this was a kind of a nice part to focus on to do this demo. So basically, the way these things come is they come with an inner shell, an outer shell, and a blank for the center. And the center can be machined into anything that you want, and then the assembly basically just bolts together. You have an inside, you have an outside, and then you've got, oops, you got two copies of an inside. And so these three pieces then bolt together with a gasket or some sealant to create an airtight wheel that you can then, you know, customize or do whatever you want. And the name of the game in racing is obviously speed costs money. And so the question is, how fast do you want to go? And one of the things that makes race cars fast is either adding power or adding lightness. And so one of the things that they like to do is they like to design really lightweight wheels that reduce the amount of weight that's spinning around and affects the suspension and all that kind of stuff. So we worked with Kerry and his team to come up with a wheel design for this aluminum blank, and this is pretty much what we came up with. And so the prep for designing this thing, or the prep for passing this thing off to machining, is first of all just doing a couple of checks. And let me just run this in shaded mode so we can see exactly what's going on here. The first thing we want to check for is any naked edges, and in this case it's showing no naked edges, no non-manifold edges, which means this is a watertight part which is suitable for machining. And then what I would do is I would just say File, Export Selected. I would export this as an individual file, and in this case, since we're using RhinoCAM, I can just send it out as a 3DM. And then basically what I'm going to do is I'm going to send Don or whoever it is that's doing the machining a part that looks like this. That's orient. I like to orient stuff around 0 just because it satisfies my personal sense of symmetry. And then I just am going to do one more couple of inspections. I'm going to run cell open poly surface. It says nothing lights up, no objects added to selection, which means this is a closed object. And then the last thing I'm going to do, just to make myself feel good and sleep better at night, is I'm going to run the check command. And check command is going to come up and say this Rhino poly surface object is valid. Okay, there's one more command we can run, which is what, and what brings up all sorts of stuff in here. The most important things are it's a valid poly surface, and it's a closed solid poly surface with 700 surfaces. All right, so it doesn't have anything in here. It's also got some data as to what's going on. All of this stuff passes my checks, so I feel good about handing this off to a machinist knowing that it's going to be in good shape. And so I would just basically save this part, and then I would email it or just file transfer it over to somebody like Don. So at this point, we'll go ahead and simulate that process, and I'll say, Don, I just sent you that part, and you can jump in and take a peek and see what kind of mess I've given you. But I think it's actually in pretty good shape. So.
Okay, Kyle, if you want to send it over to me, I'll go ahead and take control here. Okay, can you all see my screen again, I hope? And let's go ahead and we'll get the RhinoCAM part up. This is the part that Kyle sent us to machine. And obviously Kyle did all of his checks, but there's a few things that when you machine a part, first thing you do is just look at what you have that you need to machine and what is your strategy going to be to machine this. Now, what we've done for this part is we obviously have some fine surfaces here, but we also have a lot of open areas, a lot of pockets. We got some closed pockets. We got through pockets. So what I've done for this part is I've created some masking surfaces to mask some of these areas off to just help in the machining process. And I'll show you these masked surfaces up front, and then you'll see how they come into play when I show you the toolpaths. So we've just got a list of a few masking levels here. We've got mask 1, which basically covers all the holes on the outside, and it covers the large spoke pockets on the inside. But you see that the cover for the spoke pocket is at a depth below the tangent of this radius, and this depth is equal to the radius of the tool that we're going to use to cut this. So when our finishing tool goes over this area, it's only going to go down right to the tangent of the radius. It's not going to go down in the pocket area. So also, let's look at our mask 2, and that's just another masking on the bottom side, which again covers the pockets, covers these holes on the outside. This is for roughing and finishing, so we don't want to cut down into those pockets during the roughing and finishing process. And it extends this surface on up a ways so that the tool does not ride this edge of the part. So those are the two main masking layers. We do have another one which is relatively insignificant, so let's turn them all off for now. So let's go ahead and load RhinoCAM. And what we're going to do for this part is we're going to machine the bottom first. So it's a double-sided part, obviously. So we're going to have, in our first setup, is we're going to machine the bottom side. So let's flip this over and show you the stock. It's a cylindrical blank stock. Dimensions about 14-inch rim, for a 14-inch rim, about 3 inches tall. So what we're going to do here, and I'm not going to program it all, we've already programmed it, we're just going to show you the strategy that we use to program it. So we started out with mask 2 on, so let's turn on mask 2, and we did a horizontal roughing operation. We'll turn that toolpath on. So with mask 2 on, it roughs out the entire part from the bottom in levels, and ignores all the pockets and the holes and everything like that, just the contour. And I'm going to show you all these toolpaths, and then we'll do a quick simulation of it. And then we'll do a spiral finish, and then we'll do a radial finish, and you'll see that the radial finish extends up past the top of the part to the surface that we added up here to get a nice clean finish on that bottom edge of that hub. And then also the hub, top of the hub face, and then the outer profile lip with this mask on, and then the very outer profile, and then the chamfer on the hub is going to be machined on the bottom side. We don't have the hub, the whole machined yet, but we have the chamfer machine. So let's go ahead and run this simulation so you can see what this looks like. And we'll do them one at a time since we're doing pretty good on time. Let's speed this up.
Hey Don, there was a question on how you actually created those mask surfaces, so if you can talk about that.
Yes, well, let's talk about that a second. Now, the mask surfaces, let's go over, and on the top, in Rhino, we simply used these edge curves and created a surface from these edge curves and just closed that as a perimeter curved surface. And then we dropped it down by a distance of the radius of the tool, of the cutter. And then these are just, you know, planar surfaces across the holes. And this is a swept, planar swept surface using the centerline section of the part itself. to sweep that around. And then on mask 2, it's very the same. We just cut a section across the part where we have all material across the part, and then just sweep this bottom section around to create a surface that's identical to the part, but without the pockets. And then this one here is just a straight extruded cylindrical surface on the top, using this edge of the pre-existing edge of the part. Okay, so let's go back into our our simulations, and let's go ahead and run our spiral finish. And if anybody else has any questions, just type them in and we'll get to them. So there's our spiral finish, and then we'll do our radial finish. And you'll see how it gets a nice clean edge there across the top, because we're not riding on that edge, we're just going up past it. And if you don't want to wait for the whole toolpath, you can hit pause and then to end. But we're doing pretty good on time, so we'll go ahead and let it simulate. Then after that's done, we'll go ahead and machine off the top face. And let's slow this down a little bit. And then we'll do the outer lip on the outer profile here. And if you want to see the toolpaths on that, this is just to get a clean lip on this bottom side. And then we're going to do the outer perimeter in a similar manner. Let's speed this up just a little bit. Okay, and then we're going to do the chamfer in the hub on this side. And let's just slow that down here. Okay, so now what we're going to do is we're going to flip this part over on the machine, and we'll probably have a cradle that will clamp this with some probably some side action compression clamps just holding this together underneath, and we'll indicate off the center of the blank on the top. And let's go ahead and look at those toolpaths on the top. Now, this requires mask 1, excuse me. The first operation, actually, we're going to finish the outside perimeter. Then we're going to do mask 1, and then we're going to do a roughing on the entire top of the part with our holes and our slots and everything masked. Now, the inside area is not masked, so we're going to rough out these pockets in the center hub. And then we're going to do a re-roughing operation with a smaller tool and just pick up some more material that we can get at with a smaller tool. And then we're going to do our first finishing operation, which is a spiral finish. So we're going to spiral all around the part, and you'll see that the toolpath comes down onto our masking surface so that the radius of the tool matches the radius of this of the part here around each of the spokes. And then to get a good finish, typically you want to match a spiral with a radial in the opposite direction so that you get a good clearance of material. And for this demonstration, we've got a little bit large step overs just so you can see the toolpath. Obviously, in production, these are going to be tighter and get a lot of better finish on the part. And then we just go through and we cut our pockets. Let's turn off our mask surface 1. We get the pockets, and then we get the smaller pockets. And then we do the cleanup profile in the center of the hub. And then we get our outer perimeter decorative pockets. and then we pre-drill our lug holes, and then use pocketing for our lug pockets. Let's go ahead and do a simulation of this. Speed this up a little bit so we can get through this. So there's our outside perimeter. There's our roughing. Just turn this toolpath off so you can see a nice roughing pattern there. And then we'll do a re-roughing with the smaller tool. Again, just to get a little bit more material off, reduce some of the stress on that finishing tool. And let's do our spiral finish. And obviously in production, the step overs would be a lot finer, so you wouldn't see as much cusping here. But for the demonstration purposes, it gets the point across of the approach. And you see that we're not catching all of the stock material in around these pockets, and we're not worried about that because we're going to pocket those spokes out as a separate operation. What we're concerned about here is the finishing around the spoked areas, all the nice fillets and the radiuses around the spoke and the lug holes. Does anybody have any questions? Just go ahead and enter them in, and we'll get them answered for you. Okay, so there's our spiral finishing. And notice we didn't go all the way down. We stopped here. If you look at we limited it to this level right here because we're going to do a profiling operation to clean up that, the center hub area. So let's do the radial finishing. And you'll see that for this radial finishing, we had these flat areas selected, which means that in RhinoCAM, when you have nested selections, for instance, for this operation, we selected the outer diameter, and then we selected these flat areas. So the tool is not going to go in and cut these flat areas because they're already cut to spec. So we're just cutting the radial areas around the hub pockets. Let's go ahead and speed this up a little bit. Turn this off. Let's go ahead and pause that and just go to the end. As you can see, as the parts get larger, it gets a little bit longer to calculate and to simulate. And that's one thing to think about when you're designing as well as when you're programming it.
So Don, are you running this in Rhino 5 or 6?
This is Rhino 6. Yep.
Rhino 6, okay.
It's RhinoCAM 2018 in Rhino 6. So there's our radial, spiral and radial finish completed. So let's go ahead and do those spoke pockets, and we'll just get through it here real quick. But you can see here the strategy that we used, relating to the pockets, the finished areas versus the pocketing areas. We don't want the finishing tool to obviously ride down in this pocket area. So that's why we had the masking surface on top. And then we come back after and do the pocketing. So you get a nice tangent, clear edge on those hub walls. Then we'll do the smaller pockets. There's a cleanup pass, profiling pass for the center hub, and then we'll do the decorative outer through pockets. These are two operations. One's to cut the pockets that go all the way through, and if you can see the tool paths here if you want to see them as it cuts. And these are spiral pocketing with the helical entries. And let's go ahead and do the blind pockets as well. And then for the center lug holes, we're going to do a deep drill. We're going to do a brake chip pre-drill to pre-drill these lug holes. and then we'll do a through pocket to finish the lug holes. So that's it. That's the finished part. And that's how one approach. There's more than one approach to machining every part, but that's the approach that we took for this particular part. Again, if there's any questions, go ahead and type them in and we'll get to them. So now what we're going to do is we're going to go back to our slides here. Let me just pause this for a moment. So I hope everyone can see that demo slide. Thanks, Kyle. We appreciate it. Okay, and now we're going to turn it over to Anita Anand, our VP of Sales, is going to talk to us about some RhinoCAM and EDU products and resources. Anita?
Hi, everyone. Thank you, Don. Yes, like Don mentioned, I'd like to talk to you about the different RhinoCAM education products that we offer. We basically have two solutions. The first one is a network floating license, and we start at a 5-user level. It is a lab license, and like I mentioned, it's a network floating license. It starts at 5-user. You can go all the way up to a 100-user level, and you can increase it in multiples of 5. And this solution is really only restricted to a lab. And this option really seems to be the most popular choice among the schools because most schools have one department and one lab, and students use RhinoCAM in that lab. So this is the most popular choice among schools. But we do have another solution that helps schools, larger schools, to get additional seats more widely available on their campus. We call it our Campus CAM license solution. It is a campus-wide solution, so this provides unlimited number of licenses across the school network. So this means anyone on or off campus who can log into your school network has access to RhinoCAM. It is the perfect solution for schools who use RhinoCAM in multiple departments. It allows students to access RhinoCAM from outside the campus, so homeworks can be done from their dorms or their apartments, wherever they are located. Like I mentioned, it is typically a great solution for schools that have a large number of users. Now, for both of these network solutions, your school can purchase a single-user instructor key. And this key does not have to be connected to the school network. It is a node-locked license, and it is transferable between computers. So if you have multiple instructors, yes, you can get multiple instructor keys, but you can share the key between instructors by simply transferring it from one computer to another. Can we go to the next slide, please, Don? Thank you. So we do have new version releases every year. Therefore, we offer an annual maintenance subscription for our RhinoCAM users, and it is pretty nominal for our educational institutions. It covers technical support, which means this is for the instructor, obviously, and it is priority mail, phone, or live and login support, which really helps for immediate troubleshooting if you have a file that you need to use for your class. We also offer access to our CamJam instructional videos. I believe we have about 10 or 15 hours of focused training material, and this is available to our maintenance subscribers. We also offer training webinars every month, which you can gain access to through your customer portal. And obviously, you are eligible for the new version releases immediately upon release every end of the year. Now, I'd also like to point out a few other resources that you can get from our website. Don?
So while Don's bringing that up, I just wanted to, okay, let's go ahead and finish this up and then we get to questions.
Okay. So A lot of this information is available on our website, MecSoft.com. So if you go to the Industries tab on our main menu and click on Education, you get to our education portal. Now, in this portal, you get all the information about the type of solutions we offer that I just spoke about, the different lab licenses, the different options. The lab licenses, like I mentioned, they could be a fixed user level or the Campus CAM unlimited licenses. And then we also have details about the pricing, and the pricing for the lab licenses, we start at $1,250, which is for a 5-user level, or the Campus CAM solution, which is $3,000 or euros, wherever you're located. Now, the lab licenses and the Campus CAM are available in the professional or the premium configurations of RhinoCAM. The premium configuration includes the 5-axis simultaneous machining. So that is the difference between the two configurations. Another page that you can access pricing is from our e-store, right up here. And when you click on your e-store, you actually get to our e-store here, and you can go up to our education option, which gives you a whole bunch of options for your purchase. So if you go to the RhinoCAM, you can actually choose your user level all the way, and you can obviously purchase a copy of Rhino with it if you need, or an instructor license. And let's see, this basically allows you to order the product right away. Most schools use POs, which you can also send to our sales at MecSoft.com that we can help right away with. But this is a quick and easy way of ordering our RhinoCAM educational product. Now, going back to our website, your education portal, we have a lot of other information here. One is I'd really like to touch on is our resources page. We have plenty of resources for our educators to use for your class. We have webinar recordings, we have a training on the CO2 car, we have a lot of design projects and with programming details that you can use for your class. And if you have any specific needs that you would need for your school, like projects or curriculum, just feel free to give us a call and we can go through details with you. Another resource that is really useful is our YouTube channel. We have a whole bunch of YouTube videos that you could use. And if you search on RhinoCAM 2018, you get a whole slew of video tutorials starting from quick start guides to more detailed 2, 3, and 4-axis video tutorials. So these are really good resources that your school could use. Going back to our resources page, your education portal, I have a few more things that I'd like to point out. One is our case studies. We have, this page actually details a few schools that have used our products and come up with a lot of really nice projects that maybe you can go through and get ideas for your school. We have testimonials from a lot of schools and gallery which shows you pictures of different schools and that have created different projects. So this is a really nice page that you can access. Last but not the least, we do have a whole bunch of schools, a list of schools in North America as well as outside the rest of the world that use our products. Now this list is always a work in progress, and it's not a complete list as you can see, but we keep adding schools. A lot of schools have adopted our CAM solutions, starting from middle schools, high schools, trade schools, to Ivy League colleges in the U.S. and around the world. We have a large number of institutions choosing RhinoCAM. Now, the biggest reason for this is our CAM solution has been designed from the start with ease of mind in use for your use. It therefore serves a great educational tool for your students that can not only learn CAM, but they can also use it in the commercial world where RhinoCAM is used in various industries, starting from aerospace to automotive, woodworking, jewelry, robot milling, mold and die. So this is not something, it's not just textbook knowledge. They can actually use it in the real world. And as you can see in our gallery page, there are a lot of real-world projects that students in other colleges have done. So a great tool again for your schools using the Rhino and RhinoCAM combination. And at any time, if you have any questions about how we can help you in your school with RhinoCAM, just let us know. Shoot us an email and we will help you with that. Thank you all. Don?
Thanks, Anita. Let's go ahead and I'll go ahead and take that control back. And Anita did our resources, and now for our Q&A session. Joe, did we have any questions?
Yeah, so this is probably Kyle can take this question. There's a attendee who's using NXCAM and he's looking at Rhino, and he wants to know a little bit about history and associativity and rollbacks, and how maybe you can talk about Grasshopper to Kyle a little bit.
So Rhino is a surface modeler, not a parametric modeler. So if you're used to looking at something like SolidWorks or Pro-E or something like that, that's a parametric, history-based modeler, you're not going to necessarily find that functionality within Rhino. What you will have is there's model level history, which is essentially if you draw a curve and make a surface, you can go back and edit the original curves to update the surface, but it's not what you would think of like a SolidWorks modeling tree where you can essentially roll back through the model history and edit things parametrically. Now, Grasshopper, the one asterisk to that statement is that Grasshopper is actually a parametric modeling module for Rhino, which is essentially a programming language that we've now included in V6. Used to be a plugin in V5, but it's actually fully integrated into V6. So it's been lifted from merely plugin status to a full citizen of Rhino 6. Now that allows you to essentially set up generative modeling sessions that you can go in and edit parameters of that generative session and interact with your model that way. But again, being a surface modeler, more akin to like Alias Studio or something like that that's primarily designed for surfacing, you're not going to find the same parametric association that you would in something like Pro-E or SolidWorks.
One other thing I would add to that, RhinoCAM is actually associative to any changes you make in Rhino. So if you're modifying something in Rhino, RhinoCAM will know about it, and it will be associative. But there's a caveat to it as well, because what we call associativity, we classify as two different kinds of associativities. One is what we call as non-destructive edits. So if you're moving something inside Rhino, then and if you've used that object, maybe a curve or a surface in one of the machining operations, then we can still use it in the modified location or edited location. But in some cases, if you're actually changing it where you're actually deleting an object, and we have used that object in the machining operation, then we'll flag the operation as needing edits because something has changed in the model. And then if you will have to go in and reselect the newly created surface or curve that's used in machining. So that's the nice thing about the RhinoCAM is it's fully associative in the sense it'll tell you if something has changed in the model and you'll need to re-edit or reselect or regenerate the associated operations. Okay, so there was one other question about nesting. Is the nesting module included in the RhinoCAM lab as well? Maybe Anita, you can answer that.
Yes, absolutely. Nesting is included in the latest version of our RhinoCAM release, that is the version 2018. We not only include the nest, we also include an art module, which basically allows you to bring in a bitmap file and convert it into a 3D part file and use the milling options to machine the product. So again, great tools for your school to use to bring in a bitmap file, nest the part if necessary, and mill it directly, send it to your CNC machine. The other thing I'd probably want to touch, there was a quick question about post-processors. Yes, we will, we provide a whole bunch of post-processors for your school depending on the machine that you need. I think we include about 300 posts right now, but if there's anything required for your school that is specific to your machine, you just need to talk to us. We include a post-processor generator with the product, and that's something you could, simple Windows-driven program that you could use, or just contact one of us here at support and we would be able to help provide a post for you.
One other comment that Paulus, our special guest from Arizona, University of Arizona, wants to mention is that they're using both Grasshopper extensively as well as robots for machining. So Paulus, if you want to talk a little bit about that, that'll be great.
Yes, I wanted to mention that I'm running the 5-axis RhinoCAM, and my KUKA robot is taking that data and we're machining with RhinoCAM on the robot, as well as doing additive printing with ceramics with the robot. So basically RhinoCAM, again, we're following geometry out of Rhino, and the 5-axis is giving us the data to run our robot, which I know a lot of people are doing in my situation in architecture.
I had a question, Joe, for Paulus, if I can jump in here.
Yes?
Paulus, I'm curious, and maybe some of our instructors would be curious as well, is can you tell us the extent of the curriculum that for your beginning class of RhinoCAM for your students, how long it lasts, and just the basics of what you cover?
Yes, we have a lab license now, so I have 25 seats, and all of our students in our beginning class now is around 72 students, and they're all run through a basic 3-axis, 2-axis tutorial, and they're all again asked to generate the code and run the robot. So the whole 72 people do that in our beginning class.
How long is that class?
Well, it's an integrated module and a 16-week full semester class.
Oh, cool, cool.
Yes.
Was there any other questions, Joe?
There was a question about do you really need closed poly surfaces for machining in RhinoCAM? Maybe I can answer that actually. No, you don't. Even though Kyle was very detail-oriented and he wanted to give us a fully closed poly surface for machining, which is great. I mean, it's really nice if we can get good data for the machining, from the machining side of things. But also, RhinoCAM is pretty forgiving. As you can notice, as you noticed in what Don was doing, he had a lot of open surfaces to help him machine the poly surface. So the answer to the question is no, we don't need a closed poly surface, but we recommend having a closed poly surface because that means you're taking your time to design it right, and so the end product will look right. So that's any other questions? We have a couple of minutes, so we can answer any quick questions that you might have.
Oh, I have a question for Kyle. Kyle, did you guys actually build that car?
Yeah, it's actually circling tracks somewhere as we speak right now.
What kind of? Well, I didn't notice the body style. What car is that?
Is that a Dodge Challenger?
Dodge Challenger. Okay.
Yeah. Or Charger, sorry.
Or
No, Challenger. I can always get those two confused. It's a Challenger.
Is that the one that goes like 250 miles an hour?
It's, you know, I was shocked to see that the speeds that those things are traveling. When I was watching Trans Am as a kid in the 70s, you know, they were doing 120 or 130 miles an hour, but he said that car actually gets up to 215 miles an hour, so.
I've actually seen it too on some videos where the police were chasing someone that actually stole one of those cars, and they couldn't catch him. They just gave up. Finally,
Yeah.
they got him with helicopters where he finally ended up.
Or you can just wait 5 minutes for him to run out of gas.
Yeah, and he did. That's what it was. Okay, everyone. We're going to go ahead and wrap it up for now. And one thing I would like to say, I wanted to thank you all for coming and joining us for the webinar. And also, if any of our attendees, educators or students have a cool project they wanted to share with us, we'll be more than happy to you know, let everyone know about it and share your success story, both in our case studies and in our blog posts and in our webinars, obviously. So thank you very much. Y'all have a good day. Take care.